Alright, so you guys are going to look at section 9.7, which is probability models. The probability model that you're going to use for this section is going to be the probability of an event equals the number of outcomes divided by your number of total options. And to find your number of total options, you multiply all of your different options together. So option 1 times option 2 times option 3, etc. Okay, so if I look at example 2, I'm going to be flipping 2 coins. I want to know what the probability is if they land both heads up. Okay, so the probability of an event is equal to the number of options, or the number of events divided by the total number of options. Okay, so to find my total number of options, I have to look at how many options I have for each coin. So for each coin, I have the option of heads or tails. So that would be 2 options times 2 numbers of coins. So 2 times 2 is 4. So I know that my sample size is going to be 4. To find the number of events, I have to actually list out what my options are. So if I flip 2 coins, I could end up one with heads and tails. I could end up with another one tails and heads. I could end up with both of them landing on tails, or the option we want, both of them landing on heads. And so if I want them both to be heads, I know that there's only one option where that happens. So then my probability of my event would be the one option I have for it to land on both heads, divided by my 4 total options that I have when flipping my coins. Okay, so if I look at example 2b, I want to have a deck of cards and I want to know the probability that I draw an ace. Okay, so probability of an event is the probability of my equally likely outcomes divided by the probability of my sample size. Okay, so my sample size deals with my options. I have 52 cards in a deck of cards, and I'm dealing with only one deck. So 52 times 1 is 52. So I know my sample size is I have a total of 52 different options. When dealing with the probability of an event, if I'm looking at just the aces in my deck of cards, I know that there are 4 aces total in my deck of cards. So that tells me that my probability of my event is equal to 4 divided by 52, which can reduce by 4 to give me 1 over 13. Alright, so if I look at example 3, I'm rolling 2 dice. I want to know what the probability is that the total will equal 7. So probability of an event equals the probability of my equally likely outcomes divided by the probability of my sample size. Well, I know that there's 6 numbers on a dice, and I have 2 dice. So the probability of my sample size is 6 times 6, because I have 6 numbers on each of my dice, which is 36. To find the probability of my event of them adding up to 7, I have to check and see how many options I have that add up to 7. So if I roll one dice and get a 1, and the other dice gets a 6, that gives me 7. If I roll a 2 and 5, that will give me 7. A 3 and 4 will give me 7. A 4 and a 3 will give me 7. A 5 and a 2 will give me 7. And a 1 and a 6 will give me 7. So I have a total of 6 options out of my 36 total. So probability of my event is 6 over 36, which we know reduces by 6 to give me 1/6. So the probability that my dice add up to 7 is 1/6. Okay, we'll do one more where the dice add up to 5. So it's 2 dice, so option 1 gives me 6 options, option 2 gives me 6 options. Okay, so if I look with just probability of my sample size, I have 6 options on each of my dice. 6 times 6 is 36. If I look then at the probability of my actual event, adding up to 5, remember if I roll a 1, the other option that I have to roll is a 4. If I roll a 2, the other option I have to roll is a 3. If I roll a 3, the other option that I have to roll is a 2. If I roll a 4, the other option I have to roll is a 1. If I roll a 5, there is no 0 on your dice. So any number is bigger than 5, you can't roll. So I have 1, 2, 3, 4 options. So the probability of my event is equal to 4 divided by 36, which reduces by 4 to give me 1/9. So the probability that my dice add up to 5 is 1/9. Okay, so you're going to be finding probabilities using that model. This is page 707, 15 through 30.